controller in an MVC application is the traffic cop that keeps everything working smoothly. A controller is responsible for responding to user input and managing the overall flow of the application. It makes changes to the data in the model as necessary to respond to user input, and it ultimately generates a response to the user. Consistent with the separation of concerns inherent in MVC, even though a controller knows about models and views, it doesn't itself contain any user interface data or business logic code. In short, the controller is responsible for doing whatever is necessary to service requests from users, using the tools at its disposal. You can think of a controller as being responsible for application logic, how the application itself works. In this part of the course, you'll learn about how a controller class works, and many of the features that can simplify the controller code you write.
The controller in an ASP.NET MVC application is a very powerful feature, but one that's reasonably easy to use. Like virtually everything in a .NET application, controllers are .NET classes that implement properties and methods. The system.web.mvc namespace has a rich infrastructure for building controllers, designed in a way that your controllers are likely to need very little code, only what is necessary to implement the custom features of your application. All of the routine infrastructure of controllers is encapsulated in the base controller interface and the classes. It's important that you learn about and understand how the controller is implemented in the system.web.mvc namespace that is installed with ASP.NET MVC. Ultimately, a controller is a controller if it meets two simple requirements. First, that it implements the iController interface, and the name of the class ends with the string controller. Now, the class also has to be marked public, not abstract, and cannot take generic parameters. These are implementation details that, if violated, will prevent instantiating the class as a controller. If the class doesn't meet these requirements, MVC can't recognize it as a controller and will never call any of its action methods. But normally, you're going to create controllers that inherit from the controller class, which itself inherits from the controller base class. It's the controller base that implements iController, and both controller classes add the significant features that make writing MVC applications as easy as it really is. What we're going to do now is explore the iController interface and the two controller classes. Even though you're likely to only create controllers that inherit from controller, for reasons that you'll understand shortly, it's helpful to understand how all these classes together provide features to your controller classes. So let's start with the iController interface. The requirement that controllers implement the iController interface really isn't asking all that much of your controller classes. The interface's single purpose is to provide a way for ASP.NET routing to find a controller and call an execute method. It has a very simple interface definition. This is the code that implements the iController interface directly from the source code of the system.web.mvc project. That source code is written in C#. There's not a VB version of it. When a request comes into your application, when the user does something within the view, clicks on something, whatever, the routing system is going to identify a controller and call its execute method. And it'll pass in an object that contains information about the request. This request context object is quite robust. It includes an HTTP context object that exposes objects like request, response, server session, and plenty more. And you can use various kinds of information from the environment as well. So let's take a look at some code that implements this iController interface. All of this means that to qualify as a controller and meet the requirement of implementing the iController interface, all you have to do is implement a single method execute. So here's the code for the basic controller. one of the controllers in the sample application for this section. It implements the iController interface, and in order to implement that interface, it has to provide the execute method. Now this is just about the simplest implementation of a controller that you could ever think of doing, just about. So the execute method gets in an instance of this request context object, and it uses that to get reference to the HTTP context object. This is the same HTTP context object that you may have used within your web forms application. That exposes a response property, and then you can use the write method of that response object in order, in this case, to write a string out to that page. So I'll go ahead and run the application. And I'll click on the basic controller link, and as you can see, it writes out that string. Now it's very important to understand that this is the complete contents of this page. All we did is we used response.write to write out some text. There's nothing else, there's no HTML, there's nothing else there. You could use this technique in order to write out much more complex code, say by building up HTML within code within the page. But the idea here is that iController is functional. You can create pages using it and hook into some of the very rudimentary features of an MVC application, but it doesn't offer very many features. This is intentional because what it does is it allows anyone with, frankly, a lot of time on their hands to use the interface as a starting point for building a custom controller framework and then hook it into ASP.NET MVC. But for writing everyday controllers, you can do way better by using the controller classes that are part of the system.web.mvc namespace. So let's explore those classes. One level up from iController is Controller Base. This is the abstract base class for controllers that implements some of the features that make writing your controller classes very easy. It implements iController, so any class that inherits directly or indirectly from controller base will already meet one of the two requirements for being an MVC controller. Controller base adds the temp data and view data properties that let you share data between a controller and a view. The class's execute method creates the controller context object that provides context for the current request. Still, the controller base class is pretty lightweight and adds only a little additional functionality to iController for the purpose of creating your own controllers. Now you could build a website using iController or controller base, but it would either be a very simple site or would require a ton of code to implement even the most basic features that users expect in this era of web applications. Most real-world applications should create applications that inherit from the controller class, which adds far more significant functionality to your controllers. The system.web.mvc controller class is a rich implementation of all of the infrastructure you'll need to write clean, very simple controllers in an MVC application. It inherits directly from controller base, so indirectly implements the iController interface, which meets that requirement to be a controller. It also adds a number of very powerful features for controllers that inherit from controller. One that you'll use a lot is action methods. A controller can implement various methods that go far beyond that single execute method. Depending on the route definitions that you have defined within your application, each action method is exposed by a different URL and can accept parameters. You also get action results. Each action method can return one of a rather large number of action results, which are objects that describe the intended result of the action. You might return a simple string to a page. You might implement a complex view full of HTML, and that's probably the most common thing you'll do. You can redirect to another page or an action method. You can return snippets of HTML code, and there's lots of other options. There's lots of flexible things that you can do with action methods. And the controller class also implements filters. These are reusable behaviors that you can associate with a controller. And that lets you do things like use caching, control what users or groups of users can access a controller or action method, and a lot of other things. And you can create your own filters. In order to take full advantage of all these features, you'll always want to create controllers that inherit from the controller class. In fact, there's really no good reason to use iController or the controller base, unless you really want to get down and dirty with the code. And so that's the approach that we're going to take throughout this course, inherit from the controller class. By doing so, all of the controllers that you implement become containers for action methods. And that's where you get the simplified code. It lets you write custom application code without repeatedly writing and rewriting the common infrastructure kind of code. Now, in order to use controllers effectively, you have to have at least a basic understanding of the MVC request processing pipeline. Every time a user makes a request of an MVC application, such as by clicking a link or a button, then IIS, ASP.NET, and the MVC framework collaborate to run the request through a processing pipeline. The same thing happens to a request made to an ASP.NET Web Forms application, but the pipeline is entirely different from that used in MVC. Let's take a look at a simplified version of what happens for a typical request that is channeled through a controller that inherits from the controller class. And in this case, the request is going to be directed to an action method and then ultimately present the user with the view. There are lots of other options available at each step that lead to a different set of steps, such as if the controller is built by directly implementing the iController interface. But what we're going to talk about now is the most common process for a typical MVC application. So we have a request that comes through. The user does something, clicks a link, or a timer goes off, or something happens to cause a request. And that goes via HTTP from the browser to the server. IIS passes this on to the routing engine, which parses the request into its parts, including the controller name, action method name, and maybe an ID value and maybe some additional query string parameters. Then the controller factory, specifically the class named default controller factory, uses the routing data to instantiate the controller class specified by the routing data. So now the controller is in memory. Then the controller uses an action invoker. The class is called controller action invoker in order to select and invoke the appropriate action method. And this can actually be a fairly complex process because you may have many overloaded action methods with the same name. But the action invoker is charged with selecting the correct action method. So assuming that the invoker finds an appropriate action method, it then executes the method. And that culminates in a selection of a view to return to the user. And it returns that view via HTTP in the form of a response. But there are other forms of responses as well. So that's the overall request processing pipeline. Now let's talk a little bit about how the action invoker selects the correct action method